Alright, let's go over version B. You know that you'll have version B if you take your paper and turn it sideways, and there on the side it says version B. If you have version A, you'll see actually a lot of the answers are similar, not all of them, but some. Question number 1's cosine of 75 degrees is B. Cos, sine, ob is the sum identity. Change the sign. 30 plus 45 gives you 75. Question number 2, negative 35 degrees. Negative sine of 35 degrees is sine of negative 35 degrees. That's the negative angle identity. That's A. Cosine of 210 is G. Cos, sine, ob. Minus sign changes. 150 plus 60 is 210. You'll notice that there's one letter that wasn't used, which is E. Question number 4, sine of 105 degrees. That's sine, cos, sine, ob. That is the sum identity of sine. 45 plus 60 is 105. Question number 5, sine of 15 degrees. This is the cosine of 75. The reason why, if you take 75 and you put it in there, 90 minus 75 gives you 15. Sine of 15 and cosine of 75 are cofunctions. Cofunctions are complementary. Question number 6, tangent of 40 is cofunctions with cotangent of 50 degrees. Notice again those numbers, 40 plus 50 equals 90. 2 points apiece on those. Question number 7. You're asked to change that one into sine. So 2 cosine x plus 1, subtract 1, you get 2 cosine x equals 0, divided by 2 on both sides. You take the inverse. Where's cosine 0? Cosine is 0 at 2 locations, pi over 2 and 3 pi over 2. If you haven't figured out this past year, what I like to do with different versions, I switch the question around to match one of the other answers. Question number 8. 2 sine 7 pi over 12 cosine 7 pi over 12. You replace those with variable. You'll recognize this is the double angle identity for sine. The angle is 7 pi over 12, so 2 times 7 pi over 12 gives you sine of 7 pi over 6. That's not the best answer or simplified answer. That would be negative 1/2, which is on your unit circle. Question number 9. You have cosecant of 90 minus theta. You should have recognized that this is the cofunction of secant. Secant of theta equals cosecant of 90 minus theta. Question number 10. Sine squared minus 1. The answer is negative cosine squared theta. For each of these, the answer is just all or nothing. 2 points or nothing. How do I get that? Cosine squared plus sine squared equals 1, and I need it to read sine squared minus 1. So I'm going to subtract 1 from both sides, and then I'm going to subtract cosine squared from both sides. You get sine squared minus 1 equals negative. That was a common mistake for students. Negative cosine squared. And over here you have cotangent of theta. That's the quotient identity. So quotient identity, cofunctions, which are complementary. This problem is the Pythagorean identity, and this one was the double angle identity for sine. 2 points apiece. Question number 12. The common mistake is if you try to divide both sides by cosine, that would be incorrect. You have to subtract cosine of x on both sides. Now it's set equal to 0. You can apply the zero product rule. Set each of these equal to 0. Where's cosine 0? You already did it above. X equals pi over 2 and 3 pi over 2. Add 1, divide by 2, take the inverse. Inverse of cosine of 1/2 equals x. My x is equal to pi over 3 and 5 pi over 3, which is choice B. Again, that was the type of question where I just changed the trig equation, and students are trying to memorize answers and not really think. Question number 13. You had a can of a 5 by 5. You had some freebies, 2, 3, 3, and a 1. How I started the problem was I chose to start here at 15 because there's only 2 combinations of 5s and 3s. And then this is your answer. That side was out of 30 points, not 26. Turn to the back side. Use the fundamental identities to write each expression in terms of sine, cosine, and then simplify without fractions. The temptation for students is always to think, change them into sine and cosine first. But if you realize what the problem is set up for, it's set up for FOIL. First, outside, inside, last, or I did the box. 1 times 1 is 1. Negative secant theta, positive cosine theta, cosine times negative secant theta is multiplication, so it's negative secant theta cosine theta, or you could have switched cosine and secant. Alright, so let's go over this problem. It says use the sum or difference identity for tangent of negative 15 degrees. That does say a negative 15 degrees, so the common mistake is, look in your paper, all our students wrote 45 minus 30. 45 minus 30 is a positive 15, not a negative 15, so that would have been incorrect. Second thing I'm looking for is using the correct one. So here it has a minus sign. They call this the difference identity of tangent. Tangent A minus tangent B over 1 plus tangent A times tangent of B. If you had that, you got about 2 points if you did the substitution correctly. So your A value for mine, now you could have chosen something else. You could have chosen like, I don't know, someone else pick a different number? 45 minus 60 would have been correct. So your numbers might be slightly different, but I was trying to look at the math that you were using. Mine is tangent of 30 degrees minus the tangent of 45. So I'm just putting the A's and the B's back in. Over 1 plus tangent of 30 times tangent of 45. Okay, here's the easy way to know a student doesn't understand what to do. If they evaluated a tangent of 30, if on your paper you have tangent of radical 3 over 3, that's incorrect. You're doing a substitution. Tangent of 30 can be evaluated as radical 3 over 3 minus 1 over 1 plus, just use the same value, radical 3 times 1. This is how I simplified my problem. How you simplify it might be slightly different. I made this a fraction by putting it over 1 and multiplying by 3 over 3. So I get radical 3 minus 3 all over 3. Then I take the division sign, which is here, and then whatever's in the denominator, don't do any flipping, just write it. So this is a 1 plus radical 3 over 3. Again, put it as a fraction, and then common denominator. So this reads 3 plus radical 3 over 3. Change it to multiplication, then I'm taking the reciprocal. Now, pay attention. This is by multiplication. You can cancel these 3's. Another common mistake I saw students is just trying to cancel these. You cannot, because those are not factors. You have addition. Do you see that? So now I have radical 3 minus 3 over radical 3 plus 3. Now, if you notice what happened here, I went from a fraction to no more fractions. Did you see that? Some of you really struggle with those fractions, and if you think about it, your goal is to eliminate the fractions so you don't have to deal with them. Here you look at the denominator, I have to rationalize. I just changed the conjugate, plus is the minus. When I'm multiplying mine, I get 3, negative radical 3, negative radical 3, positive 9. When I multiply the denominator, I get 3, negative radical 3, positive radical 3, so those will cancel because it's 0, and then negative 9. Add those, I get negative 6. 3 and then positive 9 is 12. I factored out a 6. Factor out a 6. My 6's cancel. Negative 1 divided by 2 is a negative 2. Negative radical 3 divided by negative 1 is a positive radical 3. Negative 2 plus radical 3, or radical 3 minus 2 is your correct answer. Question number 10. So 9, that question I just went over to the same different numbering. Look here. It says, given alpha, that's the first part. Given beta, that's the second part. Use the trig identity. So if you didn't use trig identities, use x, y, and r, and you got the correct answer, I give you 0 points because you can't read. It says cosine of beta. So you don't need anything about alpha. So I'm just focusing on beta. Sine of beta is negative 4/5. Guys, use your parentheses. I can't tell you how many students did not use a substitution and they think the answer is negative 16 over 25 and they get like 41 over 25. Incorrect. Negative times a negative is a positive. Subtract it, square root, positive, negative. It tells you cosine is in between 0 and negative pi over 2. Negative pi over 2 is here. That means that here it is negative. Cosine of beta equals 3/5. Question number 17, I worked on the left-hand side. I used FOIL. You'll notice that the middle terms here cancel. 1 minus cosine squared x. Pythagorean identity, sine squared x equals 1 over cosecant squared x. Then from here to here, that's just a reciprocal identity, and I've proven the sides. So that's how I was out of 16 points. Here are my 4 terms. You'll recognize that here, secant is 1 over cosine, and cosine is cosine over 1. Here, I can cancel these to equal 1, and the reason why I can do that, cosine over cosine is equal to 1, is because you have multiplication. The common mistake for a student is over here. They like to try to cancel here. You can't do that because you have a subtraction sign. All of this just turns into a -1. This is +1. Those will equal 0. You're left with cosine minus cosine of 1 over cosine of theta. You need a common denominator with the fractions. Multiply this side by cosine over cosine. You're going to get cosine squared theta over cosine theta. So cosine squared minus 1 over cosine. Here you have the Pythagorean identity. Cosine squared plus sine squared equals 1. I want it to match just like that. Subtract 1, subtract sine squared. You'll have cosine squared minus 1 equals negative sine squared. Here, I'm changing the sine squared into sine times sine, and you only have 1 cosine. So a lot of students try to simplify that to be, say, negative tangent theta. Incorrect, because there's no power of 2. So here, this is equal to negative tangent theta, and you still have that sine. If you chose the other version, the answer is just the same answer but positive. Question number 15, the most difficult question on the quiz test. It was actually the same problem on both versions. Tangent of -15 degrees. So whatever 2 you chose, you actually has to equal a negative. So a common mistake is I saw 45 minus 30. Incorrect. 60 minus 45, those equal both positive 15. I'm looking for negative 15 degrees. Tangent of 30 minus 45. Write down the formula. Tangent of A minus tangent of B over 1 plus tangent of A tangent of B. Remember, this is the difference identity of tangent. When I do my substitutions, my A value is 30, my B value is 45, not negative 45. Tangent at 30 is radical 3 over 3. Tangent of 45 is 1. And then you can repeat those numbers. Tangent of 30 is radical 3 over 3, and tangent of 45 is 1. Did you guys notice what happens from here to here? The student who struggles is they put tangent of radical 3 over 3. They didn't understand that when you evaluate it, when you actually look at your unit circle, it was actually back in chapter 4, I think chapter 4A test, or chapter 4B test, your last chapter. You're evaluating, it's actually an exact value on your unit circle. So you shouldn't have any trig functions. You see that? From here to here, it's just a substitution. Radical 3 over 3 minus 1 over 1 plus radical 3 over 3. So how did I go from here to here? I have a 1 here. Okay, the worst thing you could have done is just start canceling things. That's what students like to do. I want things to disappear, and that would be incorrect because you have a subtraction sign here. So I take this 1, make it a fraction, put it 1 over 1. I multiply by 3 over 3, so I have radical 3 minus 3 all over 3. The denominator says 1 plus radical 3 over 3. So I change that to 1 over 1, multiplied by 3 over 3, so I have a common denominator, 3 plus radical 3 over 3. Here's my division sign, right? Division. You're going to change the division sign to multiplication, and then I'm going to take the reciprocal of my numerator and denominator here. Here I can cancel the 3's. Here you cannot cancel the 3's, nor can you cancel those. I have radical 3 minus 3 over radical 3 plus 3. If you notice what I did in my problem by doing this, it eliminated the fraction. Sorry, students just have attention. Here, I need to rationalize the denominator. So radical 3 plus 3, I'm looking at the denominator, I'm going to put a minus. That's called the conjugate. Here you're going to FOIL. You'll recognize you'll get 3, negative radical 3, negative 3 radical 3, and a positive 9. Here you'll recognize the difference of squares. You'll notice the middle terms will cancel. Radical 3 negative 3 radical 3, positive 3 radical 3, negative 9. These will cancel. 3 and a negative 9 gives me negative 6. If I combine like terms here, that's 3 and a 9. Here then I factored out 6. And then I divided by a negative 1. 2 becomes negative 2, and negative radical becomes positive radical 3. So negative 2 plus radical 3, or 3 minus radical 3 minus 2 is the correct answer. If you just wrote down the identity or you did the substitution, I give you 2 points. If you're struggling how to simplify, but you're going down in the correct direction, I gave you 3 points. Question number 16. Given alpha and then given beta, use the trig identities to solve for secant of alpha. Okay, this is very similar. Now, if you solve this problem using x, y, and r, I give you 0 points because it tells you use trig identities. Okay. Now, in this problem and the previous version, version A, notice how I gave you 2 different angles: alpha, which is in quadrant 1, and beta, which is in quadrant 4. But in my problem here, I'm crossing off beta because what Greek letter did they use? Secant of alpha. Does that make sense? You just need to pay attention. So you literally, in this problem, I just cross it off because I don't need it. I'm left with secant of 1 over radical cosine of alpha equals 1 over radical 5. Well, what's the relationship between cosine and secant? That's the reciprocal identity. Secant of alpha equals 1 over cosine. Well, what's cosine? Cosine is 1 over radical 5. So 1 divided by 1 over rad 5. 1 divided by 1 over rad 5. Change it to multiplication, take the reciprocal. Your answer is secant of alpha equals radical 5. For the student who's not showing that work, it tells me they kind of are scared of fractions and fractions. They don't know how to divide fractions and fractions. So keep doing this. Don't take shortcuts. Question number 17. You'll notice the problem is very, very, very similar to the other version. I decided to work on the left-hand side. So verify the identity. If I do 1 plus sine x, 1 minus sine x. Quick. I saw this apply about every 1 out of 5 papers. A lot of students thought this turns into cosine. And this is not the Pythagorean identity because it's not to the power of 2. Okay, even up here, you can't just start throwing powers of 2 wherever you want. Okay, it'd be wonderful if they did powers of 2 to my bank account, but it doesn't work that way. Here, if you did FOIL, you'll notice that the middle terms will cancel, and you're left with 1 minus sine squared x, which is the Pythagorean identity. From the Pythagorean identity, then I have the reciprocal identity. So you get 1 over secant squared x. That side was out of 16 points. 30, so it should be out of 46. Hopefully you didn't get minus points for boxing and being messy. You should be appreciative because I actually give you like 3 points. 2 points for name and period. Ken's not even dealing with trig. You just have to like use a little bit of math, basic math with a calculator.